Right, today we're going to look at the topic of amortization on this syllabus, and we're going to primarily be doing this using our calculators. Now, here I have a definition of what is amortization taken from a financial website, and the link to that is here. I'll put that in the links below the video. For a simpler explanation of what this is all about, you can also click on the Hayes textbook link here. Obviously, you have to have a subscription to the textbook to be able to read that link, but I'll put that in the bit below the video too. So what we can see is amortization is basically a process of repaying a loan for a series of regular payments. And if you go down to this example here, you can see a loan. This is actually something that's been written down over a period of time, and you can see it's a regular payment being paid out over that time, but the interest is calculated every month. So whatever's still left to be owed to whoever it is you're borrowing from, they will add on interest to the amount. Okay, so more will be owed due to the interest, but less will be owed because you've made a payment. And this is calculated all the way through. And you notice using these regular payments, you get down to eventually to a cost of £0 on the loan. So let's look at an example here. So we got an example. Mr. Jones takes out a loan of £1,000 to fund the refit of his VW camper. He'll repay it over 3 years at 6% annum. So what we need to do is we need to work out how to use our calculators to do this. So we go into the financial maths. So I can move my cursor across there, drop it into the financial maths, and we're just going to we're not going to use the amortization button, we're going to use the compound interest button. You can do this all with compound interest, and will equal the number of periods of repaying. I is the annual interest rate. Okay, PV here is the amount of the loan. Okay, PMT is going to be your monthly repayments. Okay, FV is the final value, which is usually 0, because we always want to pay it off. Okay, PY is the number of times repaying per year. And then if we go down, there's another one below this, which is CY, below the PY, and CY. So it's got a screen catcher, but you can see CY down here on my monitor. Is the compounding periods per year. And the pounding periods per year, and they're usually the same. Okay, the number of payments per year and the compounding periods, because when you make a payment, they usually tend to calculate the interest at that moment in time. But it's not always the same. It depends on the question. So what we're going to do is we're going to look at this question here, and we're going to calculate his monthly repayment. So he's taken out a loan of £1,000. His interest rate is 6%. So let's just go up and put the interest rate in. 6, and then we got N. Oh yeah, got to press execute to get that in. Go up to N. Now we got 3 years. So that's going to be 36 number of periods of repayment, because he's going to do one each month. Press execute on that. Then we've got to do the loan, which is going to be 1,000. Now we don't know what the monthly repayment is, so we're going to just leave that and press execute there. And then we're just going to leave everything as it is, because there's 12 repayments per month. Now we want to find out what the PMT is, the monthly repayment. So we press F4 to get that value, and it comes out as a negative. So the monthly repayment will actually be £30 and 42 pence. Okay, to the nearest pence. So that's his monthly repayment. Now to find his total repayment, then it's just going to be 36 times that number. Is how much is going to be. So let's just work out that. So let's get menu 1 and do 36 times 30.4219, and so on. That'll be enough. So it's going to be £1,095 and 19 pence is his total. So what's the interest rate? Well, the way I'd calculate the interest rate, you don't have to do it this way. You could take the 1,000 off. I don't bother taking the 1,000 off. I just divide straight away by 1,000, and which is his original amount, and we get 1.095. You should have realised that divided by 1,000, just move the decimal place. Sorry, move the decimal place 1, 2, 3 times to here, and that gives you 1.9519. So here is where you, if you think about it, one is a whole. We've got 0.095 of 100, so it's going to be 9.5% is going to be the interest, total interest charged over the time. So notice when you're compounding the interest over time, you end up paying more interest. Okay, so that's how to do that amortization equation to find out the monthly repayments. Now, there's another type of question you can get. You can get annuity questions. Okay, so annuity is when where an individual makes a lump sum deposit and then makes regular withdrawals over a fixed time period. So here we've got Mr. Dews is coming up for retirement. He has a sum of £100,000 in his savings account. He was a housemaster after all at our school, which he wants to transfer into an annuity fund. His fund earns 5.2% compounded monthly. So every month, this the bank or whoever he's put the money with is going to earn it 5.2% on this 100,000. But he wants to fund his golfing lifestyle by taking out £1,000 every month. How long will he be able to maintain this doing that? So what we've got to do is we've got to go back to our menu, go back to our financial section, and we're going to go back to F2. Okay, now this time we don't know N, so let's just delete N. We can put 0 in there. Okay, we know the interest is 5.2. Okay, we know that now in this case it's not a loan because he's taking money back. So what we're going to do is we're going to say it's minus £100,000 in there. Okay, and he's going to, and we know now the monthly repayment. He's going to take out £1,000 every month. Now, it doesn't really matter which way around you do, as long as these are opposite signs to each other, because you might want to say, well, that's the 100,000 that's not with him, and he's going to take that with him to be 1,000, so that's the positive, or you might do it the other way around. Okay, and again, we've got all the same values. We've got, sorry, I've got to put execute. We've got 12 and 12 because he's going to do it every month. Now we want to find out what N is in this case, and we see it's 131. So it's N equals 131.357. So therefore, he'll be able to do it for 131 months. Okay. Now, if he wants his money to last up to his 80 years old, how much is, assuming he is now 65 years old, he's not that old yet. Okay, one day when you watch this video, he will be, but he's not 65 yet. So we've got from 65 to 80, so that's 15. We need to do 15 times 12. 15 times 12, there you go. We don't want to make any mistakes on video, so you get 180. Menu. If you don't want to scroll all the way across, you can just press alpha and C will get you in as well. We're going to go back to compound interest. So we now know that 180, we still got the same interest. We now don't know how much he's going to take out because we want to make it last. So let's put that at 0. And we want the new PMT. So he will be able to take out £801.25 a month, and it will last him, and it's a fraction more than that, so it will last him beyond his 80th birthday if he takes that out every month. So there we go. That's how to do these annuity and amortization questions. If you didn't quite catch it, just work. What I suggest you do is you work through the question again, so you can rewind the video, pause it on a blank video, try and work out what the numbers you're going to put into the calculator are, type them in and get your answers out. Similarly here. So hopefully that will have sorted those out. We'll do some more questions in class.